Hello, my name is Stewart. I am one of the lecturers as part of the Archaeology and Anthropology teams at UCLan. And what I thought I'd do today is take you through a little bit of my research on dental metrics and biological similarity and how I've been applying this information to the early Anglo Saxon period. So in terms of a little bit of background information on what you need to know, tooth size is determined in part by environmental factors and genetic inheritance, with genetic inheritance being the more significant contributing factor. Which is great news for us in archaeology and anthropology, because it means that it's possible to use the similarity in tooth size as a means to comment on potential biological connections or relationships between people within skeletal assemblages like cemetery sites. So as a very basic premise, if we find individuals who share more similarity or greater similarity in the size of their teeth, it's more likely to indicate that they share a genetic connection. So if we are able to find these individuals who have higher levels of similarity in these cemetery sites or skeletal assemblages, we can then take that data and combine it with things like artifacts, contextual data, spatial cemetery organization, historical evidence to help comment further on broader aspects in terms of social structures like kinship and identity. But it's important to note that I'm not suggesting that a biological connection between two people necessarily means two people had to have been part of the same kin group or the same family group. And equally, those that don't share a genetic connection are still possible and likely to form kin groups together. If you think about examples in the modern day, adopted children, husbands and wives, things like that, you wouldn't expect them to have the same biology as the rest of their family. So we have to keep that in mind when we're looking into past populations as well. In terms of what's been done already, looking at kinship in the early Anglo-Saxon period, which is, for reference, from about 410 AD, the fall of the Roman Empire in England, to about 660 AD. And research from this time period has been looking into kinship through the study of things like grave goods, so looking at the significance of specific objects like spears or shields or brooches, looking at multiple burials, so when you get more than one person in the same burial space or shared burial space, does that indicate that they're part of the same family? Looking at cemetery organization, so where people are actually buried and how cemeteries are laid out, which could include things like burial structures. So I've just got an image here of Oakington Cemetery, which I'll speak a little bit about more later on, where there were some individuals who are supposedly buried underneath these mound burials, and then they tend to have other people buried in quite close proximity around them. So does that indicate potentially that these might have been, say, generational heads of different families, and therefore an important place to bury our ancestors around? So maybe that's what was going on there. There's also been some research using historical documents like wills or laws or inheritance documents, but we've got to be a bit cautious with those because they mainly pertain to later parts of the Anglo-Saxon period as opposed to directly from this early phase. And we know that human culture is dynamic. It's constantly changing and evolving due to new political and religious and economic influences, and therefore we might not be able to make a like-for-like comparison from the later period back to the early period. So we've got to be a bit careful there. And finally, there's been some studies using biological data like DNA analysis, looking at isotopes, looking at skeletal demography, so looking at the ages and the gender distribution within cemeteries, looking at things like pathology. And then what I'll be speaking about today mostly will be metric data as well that you can take from a skeleton to help you understand identity and kinship. Compared to aspects like cemetery organization, grave goods, multiple burials, biological data, with the exception of demography, tends to be a bit underrepresented for this time period in England. It's not to say that it's not there, it's just that it's not there as much. And part of the reason with that might be that both DNA and isotope sampling is destructive. So you have to actually take some bone, you have to destroy it, basically take a sample of it in order to get that information out. And it's also often, these types of approaches are often limited to smaller subsamples within the cemetery. So it's less likely that you would sample every single skeleton that you excavate for either DNA or isotopes. You tend to sort of pick and choose targeted individuals to help you with those different types of analyses. Therefore, if we can come up with an alternative, non-destructive method through which biological data can be easily obtained from the skeletal remains of entire populations, it would be really, really advantageous to add to discussions of kinship and identity in the past period, or in the early Anglo-Saxon period, which is exactly what I've been doing for the past odd number of years. So in order to help develop this methodological approach, I looked at the human remains from 4 early Anglo-Saxon cemeteries. There were 2 from the Cambridgeshire area. We had Oakington and Hatherdean, and then we had 2 from the Kent county. So we had Polehill and Eastry. And I recorded dental measurements from individuals who were around the age of 15 years, plus or minus 36 months, that had an estimated biological sex that was made via their skeleton. And I recorded what's called their mesiodistal and their buccolingual tooth dimensions, which effectively are just the length and width of the tooth. And that created a database of nearly 6,000 individual dental measurements from a total of 145 individuals across those 4 cemeteries. So yes, a lot of measuring work went into that. And then I analysed that data using various statistical analyses, which I won't bore you with today, but to try and account for that, what was causing variation in tooth size. So what was contributing to the different sizes of teeth that were being observed. So I first looked at the influence of biological sex. So if somebody was biologically male or female, how would that influence tooth size? And I looked at local cemetery environment to see that if you were buried in one of these 4 sites, would your teeth be different from those in the other 3 sites? And what I found was both of those factors really had little impact on tooth variation, which helps to reinforce the idea that genetic inheritance is what's driving final tooth size. So then, once I was able to demonstrate that all these individuals were not maybe significantly affected by biological sex or environment, I could sort the data using this cluster analysis approach to sort of have a look at seeing how individuals are grouped together based on tooth size similarity. And when looking at a population level, so when I was looking at all 4 of the sites separately, across the majority of teeth I looked at, there was this pattern that became apparent where the male tooth data tended to cluster into fewer, larger size groups, whereas the female data tended to cluster into more smaller size groups. And I'll give you a visual of that in just a moment. But what I took this to signify, or what I interpreted this to mean, is that this shows that the males within each of these 4 cemeteries were more likely to share genetic relations compared to, say, all the males and all the females, which would sort of support this idea of potentially a patrilocal residence pattern that would be functioning maybe on a broad population level. So within each of these communities, there was a core group of males, and they sort of lived there, and women maybe married in from elsewhere. And that's why the genetics amongst the males, or the teeth sizes amongst the males, looked more similar compared to the females. There were some exceptions evident, which we would expect based on, as I said, culture dynamic changing in all of these things. But overall, this was the pattern that we could see. And this is just what it looked like in terms of male versus female pattern. So the first image here shows the male pattern, where we had, say, fewer groups of clusters and more individuals within each cluster compared to the female pattern. So these are just 2 outputs from this sort of cluster analysis from the right mandibular canine teeth of males and females from the Hatherdean Cemetery. So you can just sort of see that pattern. And again, this was repeated across multiple teeth, not just this one. Interestingly, though, when I took the 4 cemeteries and combined them into one group, that pattern was reversed. So here, when we were looking at all the data together, it was the males that tended to group into more smaller size clusters compared to females who grouped into the fewer and the larger size clusters. So to sort of show you that here. So here again is the male pattern now. So it's been reversed. We've got lots of little clusters. And then for the females, we've got fewer and larger clusters between them. This was quite interesting because at first it looks like maybe they don't match up, but actually it is also interpreted to signify that male lineages were quite distinct between the communities. So each cemetery site had this sort of central or core male lineage or male-based family pattern. So when they were all combined together into the same big group, those differences became more exaggerated because they were so different. Whereas if females were more likely to be sort of moving around and marrying into all these various communities or leaving their homestead where they were born to go and marry into a different neighbouring community or something like that, we would maybe expect those differences within the 4 communities to be less distinct between the females because there's less of a pattern or less strong pull to a community for the females as opposed to the males. So that was really interesting to see. It was also really interesting to see how, if we could, take this data from the population level and look at it on an individual level to see if there's any evidence when looking at specific people or specific graves that could help reinforce this idea further. And so, looking at specific individuals, and I've just got a few case studies from the Oakington Cemetery to show you that. So the first is grave 57 at Oakington, and that was this individual here. So it was a female, a young female who was pregnant at time of death because there were fetal bones that were recovered from the pelvic area. She was also buried with brooches and other decorative objects, which would signify a close connection to the local community, to the Oakington community where she was buried. When I looked at her tooth data, I found that it was most similar to 2 older adult males in the wider community, which could be suggestive of something like a father-daughter, uncle-niece, or even a brother-sister relationship there. Which is really interesting because it kind of supports this idea that during this time period it had been hypothesized or thought that women who had married and moved away for marriage might come back and return to their father's homestead for childbirth. So if that was what was happening in the case of this female, then that would make sense as to why her teeth were showing the greatest amount of similarity to the older males in the group, potentially her father or uncles, who would have stayed at Oakington because they're part of that patrilineal sort of core family. Another example to sort of support this idea is grave 80 at Oakington. And again, this was a young adult female who was buried, but she was interred with an articulated cow, which was quite an interesting find for the archaeologists, as it was the first of this kind in Europe for this time period. So something very special going on there. So she was definitely showing a really strong connection to the Oakington community through this really unique burial. When I looked at her teeth, she was found to be most similar to 2 other adult females who were also decorated. So they had objects. One was in a multiple burial with a child, and the other was in a single interment. But they again had a level of decoration that would have shown some sort of importance or significance or connection to the wider Oakington community. So because of the close or the similarity in their tooth sizes between these 3 females, it could suggest some connection, like them being sisters or cousins, or maybe even a combination of mother and daughters or something like that in there. And because they were most similar to one another as opposed to the rest of the community, it's potentially possible that they are from the same sort of kin group originally and moved to Oakington for marriage, which is why they were showing less similarity to the males in the community compared to the 3 of themselves. But they were still shown to be really important to this community through, especially the cow, but through other grave objects that they were buried with. conclusion, so using this biological data to bridge that gap into understanding social structures in past populations. So the use of dental metrics here has shown that it's possible to create this new non-destructive approach to obtaining biological data from subsets of individuals in skeletal assemblages. And through statistical analysis, it's been shown that it was possible to identify individuals who were more likely to share a genetic connection based on their similarity in tooth size. But equally, it was just as possible to see how contextually suggested connections, so people who were buried, say, in the same grave, we could easily use this data to test to see what is the connection between them that maybe ended up with them appearing in the same grave. How does that correspond to the biodata that I was able to obtain from the teeth? So this methodological approach has shown the potential use of dental data to add to discussions on broader social aspects like kinship or mobility or identity within the early Anglo-Saxon period. And it's shown support for the idea that there were likely these core lineages within each of these cemeteries that were centered around patrilineal, patrilocal descent. And there were these different patterns between the movement of males and females during this time period. But in order to do that, it was really important to consider not just the biological data alone, but to pull in all the other contextual information like artifacts and spatial distribution, burial structures, etc., to help create these more robust interpretations. And then in future, in terms of where to go with this now, what's next, I'm going to be continuing with validation. So I'm going to be checking this method to see how it matches up against DNA analysis. And there's been some promising starts there, so that's good. And I'm going to expand my research sample to start pulling in child remains, children, subadults, especially because there were individuals who were buried in multiple graves, adults and children together. It'd be really good to see if we could pull in their teeth as well to see what are those likely connections between the child and the adult they're buried with. Plenty to read there if you're interested. And thank you very much. I hope you've enjoyed that.